Neil Ford is the director, software architect, and meme wrangler at ThoughtWorks. He also designs and develops applications, articles, video, and DVD presentations, and writes extensively on a variety of subjects. His most recent work is presentation patterns, and he often speaks at international conferences. And if you look at his bio on the app, you'll see that he's spoken at many conferences, and he's written many hundreds of articles on different subjects. Today, Neil is going to be talking to us about why does yesterday's best practice become tomorrow's anti-pattern. So please welcome Neil Ford with why does yesterday's best practice become tomorrow's anti-pattern.
Thanks very much. Thank you. Thanks very much. Welcome to day 2 of the conference. So you're all familiar with the idea of a best practice. This is something that we chase in software. That's something that is consistent and is proven to give us good results. So we like best practices, although some people kind of scoff at the idea of a best practice, but certainly that's what we go after. But we also find ourselves suffering from anti-patterns. Now, a lot of people use the word anti-pattern just as another word for bad, but that's not useful because we already have a word for bad. It's called bad. And so anti-pattern doesn't just mean bad. What anti-pattern indicates is that something that initially looks like a really good idea, but then eventually turns into a really bad thing. And in fact, that's kind of the theme of this keynote in general, is this observation that I made a little while ago that very often best practices that we adapt on projects very slowly become anti-patterns. It looks like a good idea, but then slowly becomes a bad thing. And I'm interested in why this is happening. So why does yesterday's best practice become tomorrow's anti-pattern? And there are lots of examples of this, not even in the technology world, but in the real world in front of you. In fact, some of you are looking down at keyboards right now, and you know that this is not the most efficient key layout for a keyboard. In fact, the Dvorak keyboard is much more efficient in terms of getting things done, but the design of the QWERTY keyboard was heavily influenced by the original keyboard, which was, of course, the mechanical typewriter. And the mechanical typewriter had arms that would fling up against a ribbon and bounce against a piece of paper to make an impression on paper. And so the QWERTY keyboard was laid out so that really fast typists had to alternate hands as much as possible, because the big anti-pattern with this typewriter was if you were too fast, the two arms would jam together and you'd have to untangle them and fix the little thing with the mistake with whiteout, which is another ancient technology that we don't see anymore. And so that's why the keyboard is laid out the way it is in QWERTY. And in fact, there's even a nice Wikipedia page about the origin of the QWERTY layout and why this is there, etc. But it turns out that maybe this has all been a lie all along. Because there's another article about the lies you've been told about the origin of the QWERTY keyboard. And it turns out it wasn't just fast typists, but also telegraph operators who had an influence in this design, because they had to type one-handed. And so the QWERTY layout was a kind of a compromise between one-handed typing and this ability to make alternating hands faster and faster. But this is an excellent example of yesterday's best practice becoming tomorrow's anti-pattern, because they engineered this for the best practice of the day, which was don't make the little arms jam together against the piece of paper. And now in 2016, we are still using this keyboard layout, which we will freely admit is less efficient just because this is the way we learned it. And if you want to see real pain, try to teach yourself to type again with a different keyboard layout. And it's not a fun experiment. And there are all sorts of interesting, weird side effects of little things like this. Like, for example, the missing 11th of the month. So this researcher got an interesting project in mind, and he wanted to see what is the distribution of historical events on dates. So theoretically, if you took all the events in history and distributed them across all the dates, you'd have an even distribution of events across dates. And so what he did was scan as many ancient texts as he could find, and surprisingly, the 11th of the month almost never shows up historically. Now, there are certainly big events like September 11th in the United States, and that created a lot of hubbub. But in general, the distribution of the 11th is really, really low compared to all the other dates. And this researcher tried to figure out why. Why is the 11th missing? And it turns out that it goes right back to this. Because if you look carefully at this typewriter, you'll notice there is no one key on this typewriter. Because the best practice by typewriter manufacturers, they observed the lowercase l and the number 1 had the same glyph. And so there's no reason to put an extra key on there. And so the best practice was, for one, just use a lowercase l. But the problem now, when you scan ancient text, is they keep reading the word LLTH and just think it's a misspelled word. It's really the 11th, but it's missing now because we've been treating 11 as 2 L's forever because of this stupid typewriter. So you may have noticed that one of my titles in ThoughtWorks is a meme wrangler. ThoughtWorks is one of those companies that allows you to designate your own title. I've met the person whose business card says seat warmer on it as their official title at ThoughtWorks. And this is a little bit of a self-fulfilling prophecy because a meme, of course, is this term coined by Richard Dawkins. It's a viral unit of thought. You see internet memes now, which are funny cat pictures or something like that. But it's really a viral unit of thought. And wrangle has 2 useful definitions here: to kind of herd things or to kind of mediate between arguments. And both of those things are certainly true. But it sort of became a self-fulfilling prophecy when I chose this title for myself because I've started looking for memes to wrangle. And a meme that I wrangled a couple of years ago was the one that is the basis of this keynote, which is that yesterday's best practice often becomes tomorrow's anti-pattern. And we see lots of examples of this in technology as well. Maybe the first great example of this was this paper that Edgar Dijkstra delivered to the ACM back in, I believe, 1967, I want to say. It was late 1960s, early 1970s, where he suggested that the use of GoTo may not be the best way to write software. Because all software development at the time used languages that did unstructured leaps from place to place. It was really hard to debug. And he was advocating this new idea called structured programming, and people thought he was crazy, because how could you possibly write code without GoTos? But of course, we now realize that that's one of the worst possible ways to write code. There are lots of other examples of this in the technology world. Microsoft, every few years, comes out with a brand new version of some sort of database technology, and they've used every combination of the letters D, O, and A except DOA, for I'm assuming obvious reasons. That's a common acronym in the United States for dead on arrival, which is DOA. But they've used every other combination of ADO and et cetera. And every few years they come out and say, hey, you know the thing that we were telling you to do a few years ago? Don't do that. That's a terrible mistake. You should do this instead. This is way better. This is the way you should do things now. Oh, that thing we were telling, oh yeah, that's a really bad idea. In 2007, they had some new thing, and then a brand new thing in 2008, and now they're talking about some sort of cloud thing that's going on now. Some of you may have lived through the enterprise Java beans fetish that Java developers had for a while. Maybe no better example ever of a best practice becoming an anti-pattern, because people thought this is the way that you would build software, and it turns out it's way too complicated, way too much effort on plumbing, and a bunch of irrelevant stuff. Now, enterprise Java beans is an interesting case, though, because in its version 1 and version 2, it was widely regarded as just technological poison by many people, because there was so much overhead to get useful things done. But then, in its version 3, it actually got better, and it actually got really useful, and it started to look a lot like the thing that replaced it, which was Spring. But the problem was, by that time, it already had the name Enterprise Java Beans, so it didn't matter how good it was when it came out in its new version. So here's a question for you. How many of you have seen the movie Plan 9 from Outer Space, directed by Ed Wood? That's a shockingly few number of people. You should go find this movie, because this is widely regarded as the worst movie ever made. And it's so bad that it actually crosses past the Terminator and goes over into good. It's shockingly, incredibly bad. There's a documentary about the director called Ed Wood that's about him and his making of this movie. But this is a really, really terrible, terrible movie. And sort of like Enterprise Java Beans, no matter how good the next version is, would you go see Plan 10 from outer space if you've already seen Plan 9 from outer space? So sometimes the names of things make difference. If EJB3 had been called Spring Beans or something, it probably would have been more successful. Now, during the course of this talk, I'm going to be talking about anti-patterns and other bad things. And I was always taught that it's not polite in public to say bad things about things or people. But fortunately, I have a get-out-of-jail-free card. I'm from the South in the U.S. I'm from Atlanta originally and grew up in Georgia. And one of the nice side effects of being Southern in the U.S. is that you can say the meanest, nastiest thing that you want about somebody, but then kind of automatically take it back as long as you tag on to the end of it, bless his heart. So things I've really heard my family members say, he's as dumb as a bag of rocks, bless his heart. Or she looks like she's been beat nearly to death with an ugly stick, bless her heart. So it doesn't really matter how bad it is, you kind of take it back with the little tagging on bless your heart at the end. It turns out this is regional in the US because if you're in New Jersey, the equivalent phrase is, I'm just saying. He's as dumb as a bag of hammers. I'm just saying. So that's the kind of get-out-of-jail-free card. And so you'd have to be really idiotic to create Plan 10 from outer space or use EJB3, bless your heart. So I want to pause just for a second and talk about the zen of the underscore key. Because even when computer terminals look like this, which they don't look like anymore, when they look like your computer, the Mac you have in front of you or the iPad or the phone, I keep tripping over that. That's eventually going to be funny when I trip over that. Even now, on your phone or on your iPad, you only get to type one character per cell, and the underscore takes up that cell. So what exactly are you underlining here? You are underlining nothingness. It is the most zen key on your keyboard because you cannot underline anything except nothingness with it. Nothing else will fit in that cell except nothing. So when you use the underscore, it's the most zen possible key on your keyboard. Now, developers think it was invented so we can cheat and make fake spaces between variable names, but that's not why it was invented. It goes back to this stupid thing again. Because the way that you did underscore on this typewriter is type it and then roll the carriage back and then underscore under it. And yet, we've had computers now for better than 60 years, and we still have the underscore key that underscores nothingness. And so people are going to, after this keynote, say it was supposed to be a technology keynote and all he did was talk about manual typewriters, bless his heart. So let's start talking about the reasons why these best practices turn into anti-patterns. And the first of these is something that we're calling the increased tech stack complexity. If you look at a common technology stack from 10 years ago, it was pretty simple. I mean, you could certainly change the labels on these boxes and they would have different values, but it was a pretty simple kind of basic architecture. You look at a standard kind of architecture in 2016 and it's gotten a lot more complicated, a lot more moving parts, a lot more specialization around data, around microservice architectures and all these kind of things. And one of the problems when you increase the complexity of this technology stack is something that I call primordial abstraction ooze. Every one of these things is built on top of abstractions, which is kind of a fake version of the real thing so that we can deal with it without having to think too much about the real thing. The problem, though, with abstractions is that they leak. They're never perfect representations of the thing under them. There's always a little bit of mismatch. And what happens when you keep stacking technology on top of technology is that those little abstraction leaks start magnifying. And so you get a little abstraction leak down here somewhere in the bottom, and then it starts trickling its way up to the top, and then you get to the user interface, and you get some sort of really, really interesting exception with several thousand lines in a stack trace, and now you have to figure out exactly where did this come from. And this becomes a big problem because as we keep adding more and more technologies, we add more and more abstractions, and they tend to leak. This is what I refer to as an abstraction distraction. Thinking that abstractions are always true, but often they lie a little bit, and when they leak, it's tricky. Another problem that causes best practices to turn into anti-patterns is the laudable goal of code reuse, but way too often this turns into code reuse abuse because we try to reuse too much stuff. Every company doesn't want to rewrite stuff over and over, and so they try really hard to reuse as much as possible. The problem with this, though, is that we've always been taught that software components were like Legos, where you could easily take one software component and plug it into another one. But unfortunately, the real world suggests that that's not true. In fact, John Cook has a famous quote that software reuse is more like organ transplant than it is snapping together Lego blocks. Bless your heart when you try to do this. Because it's nowhere near as easy as just unplugging something and plugging something else in. You've got to stitch up, bleeding sutures and other stuff like that. And nowhere was this more apparent than earlier this year when 11 lines of code broke the internet for like 48 hours. For those of you not familiar with this is leftpad.io. And what happened was, so the JavaScript community is sort of Wild West in terms of dependencies between things, and they don't really have any sort of name spacing or any sort of formal structure. And this guy had written a bunch of fundamental libraries that people used, including these 11 lines of code that you see right here. And he called his little group of code KIK. Well, a commercial company came into this space that had that same name, and he got kind of irritated about that, so he decided to take all of his toys and go home. And by removing this 11 lines of code, Node stopped working for like 36 hours, and Angular, and a huge number of these really important libraries in the JavaScript world, because he removed his code, and now this dependency had suddenly disappeared. There was a headline on the Register about how one developer broke Node, Babel, and thousands of projects with just 11 lines of code. Now, people say really bad things about Maven, but Maven was never bad enough to make headlines anywhere. So that's a really bad thing. If you can make headlines in a national paper that your transitive dependency management is broken, you've got a serious problem with transitive dependency management. And in fact, this is one of the biggest technical problems we face right now as developers, because what's interesting about this problem is it doesn't just affect JavaScript, it affects every single language and platform that we deal with. This problem of dependencies. This is a dependency tree from a JavaScript project out in the world. Good luck figuring out how all these things are connected to one another. But this goes back to this code reuse abuse. We don't want to rewrite stuff. We want to rely on things that other people have written, and so we attach ourselves to all those other things that people have written. But the problem with doing that is that every time you take on one of those things, you take on benefits, but you also take on some cost and some burden of making sure it doesn't break your code and making sure it doesn't disappear overnight because somebody is in a snit about something, and some other responsibilities. And going all the way down to 11 lines of code, I don't know that those 11 lines could possibly have enough benefit to offset the potential peril of relying on something like that. What's interesting about this problem, though, it is ubiquitous across all platforms. Everybody in the technology world struggles with this. In fact, one of my colleagues, Chris Ford, no relation, he's based in the UK, has a really good take on this. He says that he believes dependency management would be our go-to considered harmful moment. Because you've got to identify this problem before you can start attacking it. This is exactly like Dijkstra saying, look, this is a serious problem about how things are broken in the way we build things. We really need to rethink this in a fundamental way, and I think we're going to have to do that over the next few years. Another problem that causes best practices to lurch into anti-patterns is the fundamental problem of the software development ecosystem, which lives in the state of constant dynamic equilibrium. So you can think about all the tools and frameworks and best practices and all those things that make up software development. That really constitutes the software development ecosystem. But the problem is this is a dynamic equilibrium because new unexpected things hit this equilibrium, and it takes in that new thing and establishes a new equilibrium. A great example of this happening recently was when Docker hit our equilibrium. Because as soon as Docker became a real thing in our world and containerization became a real thing, this now affects all plans that you make about software. And this is a big problem if you're an enterprise architect and 2 years ago you created a 5-year plan for what we're going to do with software and you didn't put Docker in that plan. You can take that 5-year plan and wad it up into a tight little ball and throw it away because it is now irrelevant. Because the thing you are planning against is in constant motion. Nothing in software ever sits still. So here's a thought experiment for you. Take a computer, install an operating system and a bunch of software on it, and then unplug it from the wall and stick it in a closet for a year. At the end of the year, take that computer out of the closet, plug it into the wall, plug it into the internet, and what's the first thing it's going to want to do? 57 updates available. It has to update the operating system and all the software on it, all the dependencies on the software on it. Even though you didn't touch a single byte on that computer in that year, the entire universe kept moving along without you. Nothing is ever static in the software world, which means that traditional kind of planning that relies on static ecosystem is doomed to failure in this world. You can't make plans against something that will constantly shift in ways that you cannot anticipate. That's all I'll talk about when I talk about remediation, some ways to get away from predictability. Another problem that manifests in a lot of projects, including Agile projects, is dogma. Principles laid down by authority as incontrovertibly true. We read a book about Agile and it says that we have to do this, so we have to do this. Or some consultants came in and they seemed to know what they were talking about, so they said we should do this, so we should better do that, even sometimes in the face of evidence to the contrary. And so you have to remember that one of the core tenets of most Agile methodologies, and certainly the core tenet of XP, was this idea that you always adapt as you go along, that any sort of methodology you pick up is really just a loose set of guidelines, and you are expected to start honing it for your specific project as quickly as possible. And of course, the way that you do that and make sure you're doing better is you experiment and look at objective results. Create an experiment to test it, take that experiment, validate and quantify the data that comes out of that. From there, you can find out, did this actually do something better than what we did before? Look at that and then feed that back into the next iteration and plan. One of the premises of extreme programming was fix extreme programming. Because if you're doing something based on XP and it's not working well, you're supposed to forget about XP and fix it for this project and make it a lot better. And so the escape from dogma is real experimentation, look at real metrics and look at real results, and treat software projects more like science. And I'll talk a little bit more about that in just a second. And the last thing that makes this happen a lot is sabotage, sometimes willful sabotage. And so one of the best ways to ensure that best practices become anti-patterns is something that we call RDD, which is resume-driven development. This is trying to get every single tool or framework possible into your project so that your resume will look much better for the next job that you go to. I've had to untangle a few of these projects professionally, and it's always interesting to see how people have done that. Another way that this leads into bad places is cowboy coding, and particularly companies who encourage this. So the developer who stayed up all night on Thursday night and really hacked through and got the authentication and authorization system back up and running again gets a really good reward. By rewarding that kind of behavior, you're sending a message that we're always in a crisis, and whoever can fix the crisis is the better person, but you're just generating a lot of stress, and you're not doing a lot of the kind of engineering hygiene that you should that actually leads to more successful projects. And here's another problem that I've identified and I've seen in a lot of projects, particularly around senior software developers. So many of you remember this charming piece of software, Internet Explorer, and its first versions. And so, Internet Explorer came out, and it came to dominate the marketplace. And a lot of open source developers are not happy about that. So they said, you know what, we're going to fix this problem. We're going to create an open source browser called Firefox. And this will displace the monopoly of Internet Explorer. And so they announced Firefox, and they set out a call for developers. You can contribute to the brand new Firefox browser. And they had lots of parts to the browser, including some really cool parts, like the Gecko rendering engine, this brand new HTML rendering engine that was going to be redesigned from the ground up. They got lots and lots of volunteers to work on the brand new Gecko rendering engine. But they also needed a preview dialog. And you know how many volunteers they got for that? Underscore. Because the preview dialog is like your day job. And nobody wants to do your day job as a volunteer project. You want to work on the Gecko rendering engine, which is some really cool computer science stuff, but nobody wants to work on the preview dialog. Bless your heart, because it's too much like your day job. And this is a problem that you find with developers everywhere, particularly senior developers. Because this problem that I referred to is that meta work is more interesting than work. Most developers I know would much rather create a new framework than use a framework to create something useful. Because creating new frameworks is cool. So one of the problems is, as a developer, when you really boil down the essence of what you do, if you're describing it to your grandparents, for example, you take things from web pages and put them into databases, and you take things from databases and put them on web pages. Now, there are a lot of intermediate steps, but when you really boil it down, that's what it looks like. And the problem with that is when you've done that 20 or 30 different times, it gets kind of boring. What developers do when their day job becomes boring is invent cool puzzles to solve. So that when they come into work, they've got really hard puzzles to solve. So this is what people use branching for in version control, is to create a really complicated problem that you have to think about really hard every day. Because, the kind of database web thing is kind of dull. And so what happens in a lot of companies is your very best developers start building your infrastructure, and then you don't switch over to the open source infrastructure, and then fast forward 10 years, your very best developers are in full-time maintenance mode working on your crappy, half-broken version of Spring, when you could have just downloaded the real version of Spring and had those really good developers actually creating business value for you over the last decade or so. And so this is a perpetual problem that developers like cool puzzles, and if the problem they're working on doesn't look cool enough, they'll make it into a cool puzzle they can solve. Another problem that we run into is that some things don't scale linearly. And what's tricky about this is that some things do scale linearly, and so it tricks us for the things that don't scale linearly. So for example, code bases don't scale linearly. A 200-line code base is a very different beast than a 2 million line code base. But see, here's one of the tricky things, because modern IDEs do scale successfully from 200 lines to 2 million lines, but other things don't. And in fact, this is one of the key observations that the extreme programming guys made back in the day, was what they call pain, were these little fiddly manual things that you have to do that are kind of not the focus of the project, but you have to do to make the project successful. They call those things pain. Things like continuous integration, things like supplying sample data for the databases so that we can run unit tests on them. And you would think that as projects get bigger linearly and as code bases get bigger, et cetera, that pain would get bigger linearly. But in many cases, that's not true. Pain doesn't get bigger linearly, it gets bigger exponentially. And everybody here who's a developer knows what I'm talking about if you've used something like Subversion, because the longer you keep that out and don't synchronize it with the master, the more likely you're going to get that merge conflict, and you're going to get into the fatter and fatter part of that pain. And lots of things in software seem like they act like this. Teams also don't scale linearly. An 8-person project is a very different thing from a 200-person project. And in fact, one of the things that we've seen really recently as a big improvement around teams, this is a discussion from yesterday's afternoon keynote, was how you structure people. Because it's quite common in companies now to structure people by job function. And the problem with that is this increases a lot of coordination between these roles. And I'll talk about why, from a technology standpoint, this happens in just a minute when I talk about domain-specific architectures. But I'm sure many of you have heard of Conway's Law, which is a really prescient observation by Melvin Conway back in 1968, that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. This is an observation about the way people organize themselves and plan things and design things, and those organizations end up replicating in the designs that they create. This is a big deal in the microservices world, microservice architectures, because many microservice teams are organized differently than what we traditionally organize teams. Because in the traditional world, we organize teams by job role, but it's much more common now to organize teams around domains instead. And part of the motivation here is this observation that when you have all your user interface people together, and your developers together, and your DBAs all together, and your operations people all together, things constantly come up where developers are like, oh, I need to do this, but I need to wait until the operations guy provisions that server for me. I need to do this, but I got to wait for the DBA to do this thing for me. So there's all this incidental friction that you've accidentally created just because of the way you've organized the people. In these microservice systems, by creating these domain-centric teams, what we're doing is saying that every single time you would have to hand off to another silo, a person from that silo is sitting there on your team. And so you need something in operations, there's somebody on your team there, there's a DBA there, there's every role that you need is right there, so you're removing all this incidental friction that you've accidentally created by just organizing people in the wrong way. The common description for this is the inverse Conway maneuver, that Conway's Law is going to hit your project whether you want it to or not, so why not embrace it rather than try to fight it. If, on the other hand, you're talking to an enterprise architect, and you want to make an impression on him, you can refer to this as domain architecture isomorphism. Means the exact same thing, but you get special buzzword bingo points if you can use the word isomorphism in a conversation with an enterprise architect. But really, this is just mapping the problem to the structure of the solution, which, when you think about it, just makes sense. And the other things that don't scale well linearly are tools over time. And this is tricky because some do. Like, for example, IDEs scale essentially to the moon, but some other tools don't. So this is one of my former colleagues, Kent Spillner, and you can see he's smiling. This is a very common pose for him. Really friendly, affable guy, always making a joke and laughing around. And yet, on his blog in 2009, he wrote, "Maven builds are an infinite cycle of despair that will slowly drag you into the deepest, darkest pits of hell where Maven itself was forged." Bless his heart. So what would make a mild-mannered developer so passionately angry about a tool? Because all this is a build tool in the Java world. Well, it turns out that this is a special category of tools. What I'll talk about is being either composable or contextual. So composable tools are things like Bash or Z Shell, where everything produces text and everything consumes text. So you can wire together all sorts of interesting little combinations. If you see somebody that's really good at a Unix command line, they can do a lot of amazing things just by wiring together these little tiny little utilities. Versus more contextual systems are carrying more context as you move things through a pipeline, for example. So PowerShell is a good example of a shell where when you pipe things, what you get off the other side is a list of properties and methods and other stuff, not just raw text. Rake is a good example of a build tool that's composable because it's all language-based in Ruby, whereas Ant and Maven are examples of contextual tools. So anything that has a plugin API is a contextual tool because that plugin is giving you that context. The old school editors like Emacs and VI are very composable. They're essentially written in themselves, and so you can use themselves to write each other. Eclipse is also written in Java, but it has a really, really complex API. And if you really wanted to extend Eclipse, you could, but it would take at least a week to understand enough of the structure about how to extend stuff to be able to make any sort of substantive change. And in general, languages tend to be more composable, and frameworks tend to be more contextual. So what does this mean from a development standpoint? Well, what this really comes down to is something that I identified in my book from a few years ago, The Productive Programmer, called Dietzler's Law. So before I joined ThoughtWorks many, many years ago, I worked for a consulting company in the 1990s who did projects in Microsoft Access. And we eventually shut down that part of the business after we observed that every Access project starts as a huge success and ends in utter failure. And we wanted to understand why. And that's when we codified Dietzler's Law, because Terry Dietzler was the guy who was running that part of our business. And here's what we observed. So when you look at what the user wants, and you look at a tool like Access, 80% of what the user wants is super fast and easy. It's stunning how fast you can get to that 80% point, because there's a lot of tools and facilities to make things work really nicely. The next 10% of what the user wants is possible but difficult, because the tool wasn't designed to do what you're trying to do now, but if you're really clever, you can figure out ways to kind of hack around it, or put something here and get it to run twice instead of once, and you can get it to kind of fake this report or whatever. And so this is possible. But then the last 10% is impossible, because you cannot get far enough underneath the framework of the tool or whatever it is to get stuff done. And Dietzler's Law says that users always want 100% of what they want and are never satisfied with less, particularly some arbitrary 10% less of what they wanted, and you can never actually quite get there using tools like Access. And that brings up kind of an interesting question, particularly those of you who have been in the software world for more than a decade or so, is whatever happened to all the 4GLs? Because in the late 1990s, 4GLs, fourth generation languages, were all the rage. DBase, Visual FoxPro, Access, PowerBuilder, Paradox, all those tools. None of those tools are popular, and in fact, most of them are dead now, because they all ultimately suffered from this last 10% trap, that even though these were designed to create applications, you couldn't get far enough underneath their abstractions to get useful stuff done. So we all went back to third generation general purpose languages to do that. In fact, what has happened to all the 4GLs is they turned into domain-specific languages. So if you look at Ruby on Rails, for example, that, if it had been written in the 1990s, would have been a 4GL, but there's a key difference between Ruby on Rails or Gradle in that they're written on top of an existing language, so that when you hit that last 10% trap, you can dip down underneath the framework and get stuff done if you need to. And so there's a little bit of get-out-of-jail-free card in terms of abstractions if you write it as a domain-specific language on top of an existing language. But that's where they all went. So the point of this is that tool choices have life cycles. So Maven is actually a great tool to use when you begin a project. Because when you begin a project, everything's generic, and that's what Maven is designed for. Maven's very opinionated. It tells you what structure to put your directory structure in. And if you don't have a strong opinion about that, then it's good that somebody does. And so you put all your stuff the way you want it to. And it gives you a huge amount of benefit out of the box. But then there will come a day when one of its defaults you would disagree with, or you find yourself doing something silly, like having to compile your code twice so that you can run code coverage on it, which is a common headache in the Maven world because you can't control its life cycle enough. And so watch out for tools like that, and on the day that you start fighting with them, start looking for alternatives. Because what a lot of companies do is say, well, Maven is starting to drive us crazy, but we've already invested a year into it, so we need to double down. It's the sunk cost fallacy. But the problem with that is sometimes doubling down is not going to make it any better. It's just going to make you that much more irritated with it, because you're forcing it to do stuff that it was never designed to do, and it was never meant to scale to that level, and trying to force it to do that means you're both going to end up being mad at each other. Bless your hearts. So the name of my keynote is, why does yesterday's best practice become tomorrow's anti-pattern? Maybe it should have been how to avoid yesterday's best practice becoming tomorrow's anti-pattern. So let's talk about that, because that's really what you need to do, is to avoid this from happening. And a lot of this is a perspective shift. So let's talk about software architecture for just a second. This is a good example of the absence of architecture. This is the big ball of mud. This is something I captured from a client project where the little sub-pixel-sized dots on the perimeter here are classes, and the red lines are the connections between the classes, and the bolder the line, the more connections there are between the classes. If you've ever worked on one of these systems, you know that it's no fun, because let's say I need to change out the persistence mechanism in this architecture. Well, you start changing one of these things and you're going to get this ripple effect. It's going to touch everything else. And so architects, after they built a couple of these, they go, man, I'm never building another one of those again. And so we build a much more structured architecture, like the really common default architecture in most places, the layered architecture. And this is nice because now we can swap out the entire persistence layer anytime that we need to. I have a question for you. How often do you swap out your entire persistence layer in your architecture? Pretty much never. Because, I mean, why are you doing that? That's a lot of work, and it's going to break a lot of stuff, even though you got things well organized. But what do you work on every day? Things like customer. Where does customer live in the layered architecture? Well, parts in the presentation layer, and parts in the business layer, and parts in persistence. And so from a domain standpoint, this is not that much bigger than a big ball of mud, because when I need to work on customer, I've got to work on all the layers. I've got to touch all the pieces of this architecture, and this is not very efficient. And this is why you've seen a huge push over the last few years of people going toward domain-centric architectures. This is one of the reasons why microservices are so popular, because microservices were organized around the domains, not around the technical architecture bits. Because we realize that swapping out the entire persistence layer, while it's a nice capability, kind of pales in comparison to being able to work on customer and all the bits of customer being all in one place so I can work on them all at one time. And this is not just microservices, this is also the most common migration target that we see from monoliths that are going towards service-oriented architectures, is to build a service-based architecture which is not quite so stringent on its requirements about data isolation and granularity. But both of these are very domain-centric around this idea of build teams that look like the architecture you want, build architectures around domains, and now you have as little incidental coordination from a technical standpoint, from a design standpoint, and so we're really modeling the domain and the architecture together. The problem with this, though, is it's really cool to be able to walk around and say, I'm working on a microservice architecture. And so what we've found is out in the world, though, is that when people say microservice, what they really mean is a service-based architecture with domain emphasis and modern DevOps practices. So I'm officially giving all of you permission in this room. If you're working on a service-based architecture with domain emphasis and modern DevOps practices, you can walk around and call this microservices if you want to. Even though it's not technically true, it is cool to be able to walk around and say you're working on microservices, so I give you permission to do that, bless your heart. So domain-centric architectures have a lot of impacts on projects around team structure and the way that you structure teams, around things like governance, which has traditionally been a big deal in enterprise architecture. This is a lot more about guidance now than it is things like cost savings. So some of the core functions of things like enterprise architecture change in these kind of worlds. You have to pay really close attention to how things are coupled together and protect coupling points. And so there are a bunch of engineering practices in this world, like consumer-driven contracts, to protect coupling points as things change. And really this is about modeling the unit of change. Why don't we look at the way that we change our software most commonly and build our teams and our software structure around that? This, again, is away from the dogma of you should listen to build these architectural patterns, but toward the idea of I'm building a specific piece of software, and I should look at how this software wants to fit together and build an architecture that looks like that and build a useful unit of change. One of the ways that we're looking to get away from this is a book that I'm working on right now with Rebecca Parsons and Pat Qua, two of my colleagues, around this idea of evolutionary software architectures. And I'll give you our working definition and a little bit about our evolutionary architecture stuff. Our definition is an evolutionary architecture supports incremental guided change as a first principle along multiple dimensions. And I'll talk about two aspects of this definition. The first of these is incremental change. Because one of our goals in thinking about evolutionary architectures is to add evolvability as a first-class ility to architecture. And one of the requirements for that is the ability to move quickly and make changes at the architectural level. So let's say that we have a modern architecture, services or microservices, and modern DevOps practices. It is quite common in this world that you separate component deployment from feature release, because you want to get the component into production as quickly as possible so you can assess its readiness. Does it monitor and log correctly? Does it play nice with all the other components? It doesn't break stuff, etc. And then, sometime after you've deployed it, you turn on features by using things like feature toggles or selective routing between services. And so in this world, applications really consist of the routes that you define between components or services within your architecture. And this is that idea that underpins incremental change at the architectural level. So let's say that you're running widget code. You have a catalog of widgets that you sell to your users. And one of the things that users can do is star rate your widgets. And so you have a star rating service that's running that a lot of other services utilize. And one day, you come out with a better star rating service that allows you to do half-star ratings. And you just put it live in your architecture. You don't force anyone to move to it, you just make it available. Now, these other services, in their own time, as they want this new capability, start routing to the new star rating service rather than the old one. And over time, more and more people are going to want the better star rating service until eventually no one is routing to the old one anymore. This is one of the magic tricks that Netflix taught us about microservice architectures, is that you monitor not only the services, but also the routes between the services. And when you find a service that no one's routing to anymore, you automatically garbage collect it out of your ecosystem. This is incremental change at the architectural level. I made a new feature, I put it live without displacing or disrupting anything that was there, made it available to allow people to evolve to it in their own pace, and I got rid of the old one when it was not needed anymore. That's what we mean by incremental change. And really what this requires are these continuous delivery engineering practices and all this other engineering stuff that we've been talking about for the last 5 or 6 years. The other part of this that's interesting and makes it evolutionary is this concept of guided change. And here we're using this concept called architectural fitness function. So in evolutionary biology, a fitness function is something that assesses how well an organism is going to do in passing its characteristics on to the next generation. In software architecture, we're using fitness functions here as a way of building objective assessments to make sure that the important parts of our architecture don't break. So these may be things like metrics, these may be things like tests that we build into our architecture. So for example, any of the traditional kind of ilities that you think about in software architecture, like scalability or auditability or availability or any of those things, could be modeled as fitness functions. So the idea of fitness functions in evolutionary architecture is, look, we want to allow architectures to evolve in any way that it makes that particular domain piece that makes sense. We want it to evolve freely. But there are also some invariants that we don't want to break in our architecture. For example, scalability. We're very opinionated. It tells you what structure to put your directory structure in. And if you don't have a strong opinion about that, then it's good that somebody does. And so you put all your stuff the way you want it to. And it gives you a huge amount of benefit out of the box. But then there will come a day when one of its defaults you would disagree with, or you find yourself doing something silly, like having to compile your code twice so that you can run code coverage on it, which is a common headache in the Maven world because you can't control its lifecycle enough. And so watch out for tools like that, and on the day that you start fighting with them, start looking for alternatives. Because what a lot of companies do is say, well, you know, Maven is starting to drive us crazy, but we've already invested a year into it, so we need to double down. It's the sunk cost fallacy. But the problem with that is sometimes doubling down is not going to make it any better. It's just going to make you that much more irritated with it. Because you're forcing it to do stuff that it was never designed to do, and it was never meant to scale to that level, and trying to force it to do that means you're both going to end up being mad at each other. Bless your hearts. So the name of my keynote is Why Does Yesterday's Best Practice Become Tomorrow's Anti-Pattern? Maybe it should have been How to Avoid Yesterday's Best Practice Becoming Tomorrow's Anti-Pattern. So let's talk about that, because that's really what you need to do is to avoid this from happening. And a lot of this is a perspective shift. So let's talk about software architecture for just a second. This is a good example of the absence of architecture. This is the big ball of mud. This is something I captured from a client project where the little sub-pixel-sized dots on the perimeter here are classes, and the red lines are connections between the classes, and the bolder the line, the more connections there are between the classes. If you've ever worked on one of these systems, you know that it's no fun, because let's say I need to change out the persistence mechanism in this architecture. Well, you start changing one of these things, and you're going to get this ripple effect. It's going to touch everything else. And so architects, after they've built a couple of these, they go, man, I'm never building another one of those again. And so we build a much more structured architecture, like the really common default architecture in most places, the layered architecture. And this is nice because now we can swap out the entire persistence layer anytime that we need to. I have a question for you. How often do you swap out your entire persistence layer in your architecture? Pretty much never, because, I mean, why are you doing that? That's a lot of work, and it's going to break a lot of stuff, even though you got things well organized. But what do you work on every day? Things like customer. Where does customer live in the layered architecture? Well, parts in the presentation layer, and parts in the business layer, and parts in persistence. And so from a domain standpoint, this is not that much bigger than a big ball of mud, because when I need to work on customer, I've got to work on all the layers. I've got to touch all the pieces of this architecture, and this is not very efficient. And this is why you've seen a huge push over the last few years of people going toward domain-centric architectures. This is one of the reasons why microservices are so popular, because microservices were organized around the domains, not around the technical architecture bits. Because we realized that swapping out the entire persistence layer, while it's a nice capability, kind of pales in comparison to being able to work on customer and all the bits of customer being all in one place so I can work on them all at one time. And this is not just microservices, this is also the most common migration target that we see from monoliths that are going towards service-oriented architectures, is to build a service-based architecture which is not quite so stringent on its requirements about data isolation and granularity. But both of these are very domain-centric around this idea of build teams that look like the architecture you want, build architectures around domains, and now you have as little incidental coordination from a technical standpoint, from a design standpoint, and so we're really modeling the domain and the architecture together. The problem with this, though, is it's really cool to be able to walk around and say, I'm working on a microservice architecture. And so what we've found is out in the world, though, is that when people say microservice, what they really mean is a service-based architecture with domain emphasis and modern DevOps practices. So I'm officially giving all of you permission in this room. If you're working on a service-based architecture with domain emphasis and modern DevOps practices, you can walk around and call this microservices if you want to. Even though it's not technically true, it is cool to be able to walk around and say you're working on microservices, so I give you permission to do that, bless your heart. So domain-centric architectures have a lot of impacts on projects around team structure and the way that you structure teams, around things like governance, which has traditionally been a big deal in enterprise architecture. This is a lot more about guidance now than it is things like cost savings. So some of the core functions of things like enterprise architecture change in these kind of worlds. You have to pay really close attention to how things are coupled together and protect coupling points. And so there are a bunch of engineering practices in this world, like consumer-driven contracts, to protect coupling points as things change. And really this is about modeling the unit of change. Why don't we look at the way that we change our software most commonly and build our teams and our software structure around that? This, again, is away from the dogma of you should listen to build these architectural patterns, but toward the idea of I'm building a specific piece of software, and I should look at how this software wants to fit together and build an architecture that looks like that and build a useful unit of change. One of the ways that we're looking to get away from this is a book that I'm working on right now with Rebecca Parsons and Pat Qua, two of my colleagues, around this idea of evolutionary software architectures. And I'll give you our working definition in a little bit about our evolutionary architecture stuff. Our definition is an evolutionary architecture supports incremental guided change as a first principle along multiple dimensions. And I'll talk about two aspects of this definition. The first of these is incremental change. Because one of our goals in thinking about evolutionary architectures is to add evolvability as a first-class ility to architecture. And one of the requirements for that is the ability to move quickly and make changes at the architectural level. So let's say that we have a modern architecture, services or microservices, and modern DevOps practices. It is quite common in this world that you separate component deployment from feature release, because you want to get the component into production as quickly as possible so you can assess its readiness. Does it monitor and log correctly? Does it play nice with all the other components? It doesn't break stuff, etc. And then, sometime after you've deployed it, you turn on features by using things like feature toggles or selective routing between services. And so in this world, applications really consist of the routes that you define between components or services within your architecture. And this is that idea that underpins incremental change at the architectural level. So let's say that you're running widget code. You have a catalog of widgets that you sell to your users. And one of the things that users can do is star rate your widgets. And so you have a star rating service that's running that a lot of other services utilize. And one day, you come out with a better star rating service that allows you to do half-star ratings. And you just put it live in your architecture. You don't force anyone to move to it, you just make it available. Now, these other services, in their own time, as they want this new capability, start routing to the new star rating service rather than the old one. And over time, more and more people are going to want the better star rating service until eventually no one is routing to the old one anymore. This is one of the magic tricks that Netflix taught us about microservice architectures, is that you monitor not only the services, but also the routes between the services. And when you find a service that no one's routing to anymore, you automatically garbage collect it out of your ecosystem. This is incremental change at the architectural level. I made a new feature, I put it live without displacing or disrupting anything that was there, made it available to allow people to evolve to it in their own pace, and I got rid of the old one when it was not needed anymore. That's what we mean by incremental change. And really what this requires are these continuous delivery engineering practices and all this other engineering stuff that we've been talking about for the last 5 or 6 years. The other part of this that's interesting and makes it evolutionary is this concept of guided change. And here we're using this concept called architectural fitness function. So in evolutionary biology, a fitness function is something that assesses how well an organism is going to do in passing its characteristics on to the next generation. In software architecture, we're using fitness functions here as a way of building objective assessments to make sure that the important parts of our architecture don't break. So these may be things like metrics, these may be things like tests that we build into our architecture. So for example, any of the traditional kind of ilities that you think about in software architecture, like scalability or auditability or availability or any of those things, could be modeled as fitness functions. So the idea of fitness functions in evolutionary architecture is, look, we want to allow architectures to evolve in any way that it makes that particular domain piece that makes sense. We want it to evolve freely. But there are also some invariants that we don't want to break in our architecture. For example, scalability. We want to make sure that we can preserve things like scalability even though we grow. And so the idea of fitness functions is you define fitness functions that are run as part of a deployment pipeline that every time you make a change assesses, have we broken this fitness function or not? So another good example of this are consumer-driven contracts, which is really popular in the microservices world. The idea of a consumer-driven contract is I have a service provider and I have a consumer, but if these two services are allowed to evolve in any way that they want, how can we make sure that their integration points don't break? The consumer-driven contract says the consumer hands the provider a set of tests that encapsulate what it needs from the provider, and the provider will run those tests and keep them green all the time. That's an integration architecture fitness function. What we're doing is building a test to make sure that even though these evolve in ways that we can't predict, there are some things that we don't allow to break. And so anything that you would traditionally capture as a non-functional requirement can be captured as a fitness function, but also these characteristics about can we allow things to evolve freely. And so that's really what we're writing about in this book, is how do you build architectures that have these characteristics that allow them to evolve more or less freely. And our goal here is to try to build adaptability into architecture. Because as I mentioned before, because of dynamic equilibrium, predictability is shot in software. We cannot rely on predictability anymore. And this is a big problem if you're trying to make long-term plans, which we don't really think are possible anymore, because you can't plan against something that may fundamentally change tomorrow in ways you can't predict. And so rather than getting better and better at predictability, we're trying to get better and better at adaptability and evolvability. One of the problems in software architecture has always been that the architecture parts are the parts that are hard to change later. But then when you build change into the architecture, like we did in microservices, suddenly change becomes a first-class citizen in the architecture, and you can start thinking about that like you think about all the other characteristics in the architecture. And so we're trying to build evolvability as a first-class ability in architecture. And the other way to avoid this problem is something that I mentioned before, which is embrace experimentation on projects. This is the way to get better on anything, is don't rely on someone's best practices or someone's dogma that's come into your organization. You need to prove to yourself this is working or not. Find a way to capture objective results on something and start measuring it, and then start hypothesizing, could we actually make this better? And in fact, when you get to things like really good continuous delivery engineering practices, and when you build an evolutionary architecture, this gives you a superpower that you never had before, which is this idea of hypothesis-driven development. So this is talked about a little bit in the Lean Enterprise book. Barry O'Reilly came up with this idea, or popularized this idea. But with evolutionary architecture, we now have some of the building blocks for this. Because the idea in hypothesis-driven development is once you have a base piece of software, a minimum viable product, you can start thinking about building stuff in a different way. You still have your vision and strategy and business goals, and you still have the ideation process, but ideation here is not what new requirements can we implement. Because metaphorically what you're doing right now is cooking a buffet. You're going in the back, you're coming up with these recipes, you're cooking all these dishes to completion, and you're laying them out in front of your users. And some of them really like your dishes, and some users treat your dishes like vegetables. And it's hard to predict which is going to be the most popular ones. What we're saying instead is, let's not cook the whole buffet. I'm just going to give you a taste. If you like this, I'll give you more of it. And if you don't like it, I'll stop cooking this. And so ideation in this world is hypotheses. How do we hypothesize to get something better? And that leads to a collection of experiments that you can run. Then you start selecting experiments and you run them. Some of them may start giving you some good results. Of course, these are all tied to feedback loops. They like part of it, but not one aspect, but not the other aspect. And so this is the classic pivot in software terms. Maybe you start working on one thing that looks really promising and it's just not good. And so this allows you to fold your effort early and not waste time on it. Maybe one of them really does good, and this allows you to put more effort on this and really double down and make this a lot better. There's a great case study. I've got a talk that you can download from my website around hypothesis-driven development. It includes a case study from a mobile app developer in Germany. And they found themselves backed into a common corner. This is another one of those best practices that leads to anti-pattern, in that this is a mature application, and they've had business analysts for years suggesting new features. And while every feature alone made sense, when you combine them all together, it created a really jumbled user experience, and their users started falling. The people who are using their app to actually buy things started trailing off because things got too complicated. And so they created 3 hypotheses. Do our users like more structure, more context, or better prioritization? They built 3 different versions of the app and put it out there and let the users decide which the better version was. Let them actually determine what direction they should go in the future. Rather than speculating and guessing and spinning their wheels, they got real feedback from their users. Of course, the engine of agile software development are feedback loops and nested feedback loops. If you look at any agile methodology, it's all about nested feedback loops. But there's one feedback loop that has always eluded us, which is one that includes the user too. What hypothesis-driven development allows you to do is get the user into a feedback loop for the first time and actually learn things directly from their behaviors to drive the way that you build software. And so this is a much smarter way to build software because you spend less effort building things that people don't want, because you can find out much more directly what people actually do want and like. So to conclude this, I am, of course, a consultant by trade, and there is a phenomenon out in the world known as the out-of-town consultant effect. And what this means is that if I rode on an airplane to get to a meeting, I automatically have more credibility than the people who only rode in cars to get to that meeting. That's the out-of-town consultant effect. But there is a grain of truth in the out-of-town consultant effect, because when an out-of-town consultant comes in, they're looking at things with fresh eyes for the very first time. So many of you have read the story in the Pragmatic Programmer book about boiling frogs. So apparently, if you want to boil a frog, you can't just throw a frog in a pot of boiling water because he will intelligently just jump out. But if you put a frog in a pan of cold water and then turn the heat up slowly, the frog will cook without realizing it. This is a famous story from the Pragmatic Programmer book. It turns out that frogs are not that stupid. As soon as it gets uncomfortable, the frog will jump out of the pot. But big companies are that stupid. Because you do these things, you start doing these things, and you're doing them, and then an out-of-town consultant comes in and says, you know you're jabbing your fork into your leg, that probably hurts. If you would stop doing that, it would stop hurting. And you go, hey, you're right. I should stop jabbing my fork into my leg. That's such a relief, thank you. I didn't realize I was doing that. Because I started just tapping it, and over the years it became jabbing, and it became really painful. And so my best advice for you is to be your own out-of-town consultant. When you go back to work later this week or early next week, look around at all the things with fresh eyes, as if it were the very first time you saw them, and ask, does this make sense that we're doing this, or is this some sort of boiling frog thing that we've just been doing for a long time, and we haven't realized that this best practice has turned into an anti-pattern? Now, I'll give you some warnings when you start poking around and lifting up corners of things that haven't been lifted up for a long time and start looking at things. You're going to probably find some dumpster fires running around in your organization, and you will probably bump into some people who are responsible for those dumpster fires. And remember, it's okay to say bad things to them as long as you remember to bless their heart afterwards. Thanks very much for coming. Hope you enjoyed it. Thanks. Thank you. Thank you very much. Thanks, and enjoy the rest of the conference.
Cool. We have time for a couple of questions. Are you open to questions, Neil?
Sure.
Cool.
I don't want to run into the next session, but I'll happily answer questions. Yes.
So I've been toying with the idea for a couple of years. You've kind of named it domain-centric architectures where everything's structured around the domain. Have you thought of or seen any parallel in the manufacturing world with the move from traditional activity-based architectures to something like single-piece flow?
More and more, but they're slower to move because they have so much stuff.
So my question is, do you see that as the same, as an equivalent move?
Yes, I do. In fact, we just, one of our big success stories from Germany just recently was, we're working on the software for Coffee Pot. And we wanted to do continuous delivery, and the traditional manufacturing process flashed the chips on the coffee pot like once every blue moon, and we actually got them to change their manufacturing process to flash the chips every single time it goes down the manufacturing line, not like once a month now. So we can make hourly changes to the actual software running on the chip and get it flashed as part of the production line. That's a great example of people are slowly coming around to that, but it's just harder because there's so much physical stuff they have to change and reorganize. But I think the benefits are clear, just like there is in other kinds of architecture.
So that dependency mesh you mentioned, which is on all the platforms, especially especially Node, it feels like pre-2008 financial crisis where everyone was getting bonds and you're part of you're dancing with it. And you know, that's the trend. You're building React, you're building Angular sites, and it draws you in. You know there's something wrong. You know there might be a financial crash.
So
What advice do you give a
So I actually have
developer?
advice on this, but people are not going to like it. You've got to start doing dependency governance. So I suggest, and I actually have a different version of the schema that's a little more technical, building an immutable store yourself inside your firewall of all your dependencies. And you take pull requests into that from the outside world. So when Knucklehead removes his 11 lines of code, you reject that pull request because that's going to break all my code. I don't want that to happen. So I think we're going to have to start doing, in fact, so this is one of the weird things. Governance is moving away from kind of cost savings and saying no to every request that developers come to them with, and more things like governance around dependencies, because that's where you need governance now, is how should we take on this dependency? Is this dependency stable, et cetera? So I think that's going to be the ultimate solution. But
So every dependency should be a decision.
absolutely, it is a decision.
It is,
It's just
but
too casually done now.
explicit.
I mean, you get JavaScript projects now that literally have thousands of dependencies, and some of them are 3 lines of code. And particularly in the JavaScript world, I mean, you know, JavaScript's a little bit Wild West in terms of state. So there's 2 famous cases I'll talk about in JavaScript. One of them was, so there's a JavaScript dependency that literally just is a thing that returns true. And then some idiot hacked it to return false because he needed it to return false in some weird edge case thing. And so now you have this thing that's literally only supposed to do one thing that does the opposite of what it's supposed to do. So that's nice. The other one was they did this as a proof of concept. When you do plugins for things like Angular, one of the things you can do is specify that when the plugin starts up to run a shell script for you. And so they wrote a module that when you install the module, it did an rm -fr/. So it basically just deletes your entire hard drive as part of its startup, just as a proof of concept that, look, you trust these dependencies, but this is an attack vector like no attack vector ever, because you're allowing them into your development ecosystem where you can execute stuff freely. That's not good. So yeah, we need some sort of governance on this. Because here's my prediction, and I hope this is not going to come true, but I'm afraid it's going to come true. Massive security hole opened up in JavaScript applications through transitive dependency management that people weren't managing successfully. So it's going to happen, I think, sometime.
So, yeah, thank you so much, Neil.
Thank you.